Hello everyone, welcome back to another AP Chemistry kinetic tutoring video. Today we're covering 1.2 mass spectroscopy. So let's get straight into it. Um, Here we're given a mass, an atomic mass or an average atomic mass. We're supposed to calculate the average atomic mass, given that 57.4% of the time, the atomic mass of this element is going to be 121, and 42.6% of the time, the atomic mass of the element is 123. So first we need to calculate the atomic mass of this element. And so what I'd like to do in order to calculate the average mass is you get the percentage, 57.4, you divide it by 100, and then you multiply it by the mass, 121. Excuse me. And then you do the same thing with the other one. Excuse me. 42.6 over 100 times the other mass, 123. Notice how this 42.6% matches up with the 123, and this 57.4 matches up with the 121. So you go ahead and do that. 57.4 divided by 100 times 121 plus 42.6 divided by 100 times 123, and you will get the value 121.9 if we're rounding to one significant figure in after the decimal, 121.9 grams. So there you go. And then it asks, what is the most likely identity of the element? So we take a look at our periodic table, see which element is closest to 121.9, and it's going to be antimony, SB, and I'm not exactly sure how to pronounce that, SB. We'll just call it SB. So there you go. That's how you would calculate what element it is, and you could have really done this without this calculation of the average atomic mass, because you take a look, see that the element is between 121 and 123, and that's the only element that really fits the description here. So let's take a look at a second example. A certain element has two naturally occurring isotopes with mass numbers 63 and 65. So here you're forced to do what I just was talking about, 63 and 65. So what is the most likely identity of this element? The only one that's below 60 or between 63 and 65 is going to be copper. So that's what we're going to put, Cu, and then fill in the table below. The mass number is always going to be the protons plus neutrons, because remember, electrons have very close to zero mass. So if we take a look at copper, copper is 29th on the periodic table. So that means that the number of protons is going to be 29 no matter what, or else it would be another element. Now the number of neutrons is going to be 63 minus 29, which gives you 34. And in this case, it's going to be 65 minus 29, which is going to be 2 greater than 34. It's going to be 36. All right. Now it says, which isotope of this element, mass number 35 or mass number 63 or mass number 65, is more abundant in nature? Justify your answer. All right. So just taking a look at copper, 63.546. It's in between 63 and 65, but as we can see, it is a lot closer to 63 than it is to 65, because in the middle of 63 and 65 we have 64. 64 would be smack in the middle, and as we can see, 63.546 is going to be less than 64, so therefore it is going to be closer to 63. and therefore 63 is more abundant in nature. All right, here we go. We're given a more complex, nuanced equation where we have to do the same thing. So once again, you divide the percentages by 100, so 2.18 becomes 0.0218 times 154. 0.0218 times 154, and then you add the next one, 0.148 times 155. You keep going, 0.2047, 0.2047 times 156, and you keep adding these, by the way. And then you have 0.1565 times 157. You add 0.2484 times 158. And then finally you add 0.2206 times 160. And this gives you 157.34. 157.34. There you go. And now, once again, what is the most likely identity of this element? We just take a look at our periodic table, see which element is closest to 157.34. And it's going to be down here. And I believe it is gadolinium GD, because that's the one that is very close to this value, 157.34. This is 157.25. You know, we're only off by 0.09 grams, and the other ones are going to be off by around 6-ish and around 1. So there you go. That's how you would solve it when you have 6 values, which is a little bit more complicated. But all it is a little bit more calculator work. It's not too troubling, nothing too bad. Yeah, that's how you solve these problems, and that's all there is to 1.2. If you guys have any further comments or questions, make sure to leave them down in the comment section below. And if you enjoyed the video, make sure to like and subscribe. It really supports the channel, and I'll see you guys next time.